Hello, how are you all? Great to see you again. It's the longest title in the world today, Wired and Wireless Protocols and Layers. Please introduce yourself in the comments. Do say hello. Nice to know who's here. I hope that your lives are happy and well, and it's a bit warmer and it's a bit less dark, isn't it? It's all rather nice. Okay, we've got a fair amount to do, but let's have a look back first of all at something we did before, and that is some of the questions we covered last time. What about this one? Which of these are true for mesh networks? Mesh networks we looked at last time. Have a think about what that could be while I figure out what's going on over here. So what do we think? This type of network requires a switch. This type of network would be used in a home, and this type of network may be very expensive to set up. What do we think it may be? Ooh, I can see some people. Let me try and work out why I can't see the comments. Hang on a second. Ah, here we are. Hi, Dom. How you doing? Thanks for coming. Hi, Jelly. How are you? A says Dom. And hi, Laura. Laura says B. Should we have a look? It is, dun dun dun. It is C. Expensive. True from, was that the right answer to the right question? Yes, it was. Okay. All right. Let's try this one. What does DNS stand for? Jelly had C, please. You were right for the last one, by the way, Jelly. You were the superstar. So, Jelly, you were the star of the show. Dom and Laura is always the next one. What about this one? What does DNS stand for? This is the... Oh, was it Max? Ugh, well, you know, you can't get the staff, can you? This is what happens. Thanks for nothing, Max. What about this? DNS. Hello, Josh. How are you? Thanks for coming. I had a bath when I got home. I fell asleep in the bath and woke up 2 minutes ago thinking, I've got to do this. Jelly said C, domain name system. I like it, domain name system. That is, you're absolutely spot on. It is domain name system. So let's go to that one. Do you know what? It says domain name server. The truth is it can stand for either B or C. So Josh, your call was solid there, but Jelly, so was yours. It actually stands for domain name system, but there is a thing called a domain name server. So either is good. It's the addressing system of the internet. Do you remember the domain name? So google.com is a domain name, but the URL would be HTTP, google.com/news. And the news bit, that's the resource, and the HTTP is the protocol, hypertext transfer protocol. What's the role of a web server? Any idea on this one? To control centralized access to a website, to allow the user to create their own web pages, or to request a specific web page from a web host and display the results. What do we think is the answer? Ooh, Dom is straight in with C. Jelly is in with C. I like your avatar. And Laura is straight in with C as well. You guys are superstars. Oh, to control centralized access. Well, do you know what? I've got to say, it actually is C. To control centralized access to a website data, including content and layer. Do you know what? It could have been either A or C, because the relevant web server is actually, it is A and C. So either A or C would have done there really well. Yeah, I like that. That is cool. All right, let's push on. The role of a web server is to serve up web pages, and it's a big, powerful computer with lots of storage attached, and it serves up web pages. You've got a print server, you've got a web server, and a file server, and they serve up the print queues, web pages, or files. Right? That is their job. What is meant by hosting? So hosting is often what we describe as who you're with. So whether it's a Virgin or BT or Sky or whoever, it's who you're with. So what's meant by hosting? Is it A, B or C? What do we think? A, B or C? What have we got? Hello, Rukshan, how are you? So hang on, we've got Dom who said B. We've got Rukshan, hello dear man, how are you? Hope all is well. You've also said B. Any more takers on that one? A, B or C? Laura's coming B. Look at that, outstanding. Let's have a look and see what the answer is. You are all nailing it. That is very good indeed. So let's do the next one. Have I got one more? I think I've got one more. Oh, two more. Cloud computing. Cloud computing. No one knows what cloud is. Yeah, Jelly, I'll give you the benefit of the doubt. You've nailed this all so far, so that's absolutely fine. What is cloud computing? Dom has come straight in with C. Dom is on fire. I mean, not literally, I hope not. But that's pretty good. She said, it's using the internet to store and access data in programs. Josh and Rukshan and Laura have all come in with C as well. So I think that is pretty good. Let's just confirm that with you. It is C. You are all outstanding. Yeah, Josh said C. This one, I throw this one in each week because no one ever remembers the registers. This is the bit we're doing this term, by the way, this half term, going back and doing system architecture again. How many of these can you remember? Remember, we've got the memory address register, we've got the memory data register, we've got the program counter, and we've got the accumulator. Those are the four. Ta-da! Which is which? Which is which? The memory address register, the memory. So if you write them in order, MAR, MDR, whatever order you think it is, what would it be? Stores addresses where data will be read. So just write 4 for ABCD. So the address where data will be read, the address of the next instruction to be run, the result of calculations. We've got 16, 18 in, which is pretty good. Oh, hello, let's have a look. I think Dwight McNeil. I think you need some help, Rajan. I think you're suffering from some kind of memory problems here. You can't have seen the wonderful Bukayo Saka. It can't be possible. It can't be possible. Oh no, it's Rajan. I see. Well, he's already said something very dubious, Jelly. So, you know, this could be a worry. Okay, so let's have a look. Dom has said MAR, MDR, ACC, PC, and Rukshan has said MAR, MDR, accumulator, PC, and Laura has said MAR, MDR, ACC, PC. You guys have done really well, actually. So let's, here we go. The address is either going to be MAR or PC, okay? So the MAR, so I think you guys were right. You had MAR, MDR, accumulator and PC. MAR, MDR. Yeah, you all got it absolutely spot on. That is so good. That is outstanding. And they're difficult. And I think once you strip away the sort of levels of complexity, once you know what each of these little registers holds, then you are... And Laura, yours was right too, wasn't it? MAR, MDR, ACC, PC. Outstanding. Yay. That's good, because that's not easy. Right, how long have we done? Where's my clock? 18:37. Okay. All right, so wired and wireless protocols, layers and so on. What's it about? Here we are, 1.3. So we've done the first two. We're into this bit of the spec of J277 paper 1, and this is what it covers. And I've actually taught this to my two classes quite recently, and it's the protocols and it's the concept of layers. This, I mean, I think I'd probably say this about every single question, but there tends to be 8 to 10 marks on this part of the paper, which is a grade boundary and a bit. And I think it's actually fairly easy to gain marks on this because there's only so many ways they can ask it. So your job is to figure out what these different protocols here are, and the protocols is all this stuff up at the top here. Where have I gone? The protocols is all this stuff up at the top here. These are all your protocols that you need to know, and we need to figure out what they are and what they do and what they're used for. And then we'll look at this idea of layers, which is slightly more abstract, but that wasn't in last year's exam. They took it out because of COVID. You've had no such luck. They're making everything horrible for you. It seems to be that your year group's job is to suffer, so I hope you're enjoying that. So you need to know that a protocol is a principle for a set of rules. We'll talk about that definition, but I think you know that anyway. Different protocols have got different purposes and are often used by different equipment, actually, and how layers and protocols fit together into this architecture of an architecture of transmitting data and the internet, I suppose we can talk about. You don't need to understand how the protocols work. You don't need to understand anything about IP addresses beyond the fact you've got IPv4 and IPv6 and what they're for. You don't need knowledge of individual standards, and you don't need to know the names and functions of each TCP and IP layer. I'll cover it briefly, but you don't need to know the functions of each one, just what the benefits and disadvantages of layers are. So I've got some stuff on that, but I'm going to skirt over it fairly quickly. It sometimes helps to know the story a bit anyway. So let's go for a 10-minute teach. Definition-wise, very early on, they hit you with this idea of what is a protocol. It's a set of rules, one mark, that allow devices on a network to communicate with each other. So protocol is a set of rules, and it's usually around transmission of data. These are the ones that we're looking at. A protocol is a standard way of doing things. And the benefit of using protocols is that it means that the set of rules can be cross-platform, whether it's PC or Mac. It can be, cross-device, PC or Mac, cross-platform, Windows or iOS or OS X or Linux actually, and it'll work across different platforms and different devices. All right, so that's the benefit there. Now these are my new diagrams. There's a foot sitting on my beautiful head. These are the protocols that you need to learn. The problem is, learning these abstract terms is quite difficult because they're not the most exciting things to learn. But you can see top left, that's a TP. So we've got SMTP, we've got IMAP, next one along. We've got HTTP, see the golf tees up there? It took me ages to think of that. I was ever so proud of those, the HTTP. And these are Ps. The fact I need to explain my diagrams kind of says it all, doesn't it? And then we've got POP down here for the post office protocol, and then we've got TCP/IP. You see T as in teapot. Do you like to see what I'm doing there? Teapot. C as in glasses, and P. I know these are worse than my diagrams on the board. And then we've got FTP here. Feet. It's close. It's the best I could think of. So those are the 6 that you need to know, and you really need to understand what it is they do. And these kind of group together in a way because you've got a couple that are about email, and the rest are about how data's moved around. So let's jump in and have a look at these one by one to make sure you're happy with what they do. So TCP/IP, which was this guy here. Where is it? TCP/IP down here. This one here. Okay, that's the TCP/IP. So let's jump in and have a look at that one first. So it stands for Transmission Control and Internet Protocol. This is what Bob... oh, hi, Krish. How are you doing? That's a mighty lion. Well done. Yeah, TCP/IP. Although it's the lionesses that do all the work. The lions just stand around moaning. Yeah. Anyway, TCP/IP, Transmission Control, Internet Protocol Control. This is what Vint Cerf and Bob Kahn, these are the protocols these 2 guys and a team of others wrote. And this is really what underpins the internet. This is how packets are sent on the internet. And we know that when you send data via the internet, data is chopped up into packets and it's sent across the network in that way, in small packets. The packets are numbered and the packets are rearranged at the other end. And sometimes they arrange in a different order because they can be sent via the quickest route at the time. So the transmission of packets, so TCP, this part of the protocol here, the TCP bit, this takes care of this bit, which is sending the data packets, splitting the data into packets in the first place, reassembling at the other end, and making sure that what was sent is what's arrived. So that's the TCP bit. I'm going to use my hands by way of an explanation. Does that work there? So these 2 layers sit on top of each other, and TCP passes to IP and IP passes back. So these 2 layers talk to each other, and we'll get a bit more into the layers in a second, but these both sit on different layers. So that's TCP part. Let's look at the IP bit, this bit here. And IP is responsible for, it's about the addressing really, and it's about the addressing of packets, and it uses IP addresses. And we know we've got IPv4 and IPv6, version 4 and version 6. And of course the idea here is that every device on a network has an IP address, okay, an internet protocol address. That way it can be found, it can receive data, and it can send data. So version 4 didn't have enough slots, enough memory slots, because when the internet first started, not many people had a device, and people only had one device to connect to the internet. Now, if you count up the devices you've probably got half a dozen devices that in some way connect to the internet. Okay, so that is TCP/IP. And I've got something more colourful and exciting here, which is just some key ideas about TCP/IP. It specifies how data is transferred. They're two separate protocols. This is what they do. I will ping you this PDF so you've got this afterwards. But I've kind of covered this. The message is broken down into packets, and it's reassembled at the other end. And I mentioned before that each packet could take a different route. And this is why it's so, I was going to use the word cool. It is pretty cool. This is why it's so cool, because if one node goes down, or one route goes down, or one route gets congested with traffic, it just goes via a different route. And that means that your data is far more likely to get there. What's quite interesting, I was just teaching the A-level group today, is there's a sweet spot for the right size of packet. If the packet's too small, it means you're sending too many headers and footers in the packet and too much information. If the packet's too big, it'll get corrupted and take ages to send. So there's a sweet spot about the packet size, but we don't need to worry too much about that at all. All right, so that is TCP/IP, and that's the sort of information that you need to know. Then we've got HTTP. So thinking about your web address, you type in http://www.google.com, right? HTTP is the protocol because you're using the hypertext transfer protocol, all right? So it's used to transfer web pages, text, images, and sound over the internet. And the hypertext transfer protocol dictates the format of the data and the commands that are used between web servers and browsers. The browser being Chrome or Safari or Edge, whatever you use, okay? HTTPS exactly the same, this one here, except it has got the S on the end, and the S stands for secure. So that's end-to-end encryption, and my groups will know because as though I'm trying to create some cult, get everyone to repeat the fact that encryption is turning plain text into ciphertext so it's rendered unusable if it's intercepted by a third party. Yeah. Okay, so that's what that one's all about. All right, so we jump into some details. The top two are important. I thought I'd make that clear by writing the word important next to them. It stands for Hypertext Transfer Protocol, and it's used mainly for the World Wide Web, okay? The rest of it is useful, but they're not going to test you directly on that. But it's what web browsers use, okay? And again, this sits on a higher layer. This sits on the application layer up at the top, which is where the users actually interact with the system, okay? So those are the key features of HTTP. Let's go on and look at the next one, FTP. This was my feet, well, not my feet, but the image of the foot. And this is about transferring files across the network. So imagine that you are setting up a website and you've got 100 pages and you've got 300 images and you've got 20 videos and you've got a lot of text. How are you going to take it from your computer onto the web space? So you've rented web space, you've gone to GoDaddy, or you've gone to one of these internet service providers, and you've bought some web space, okay? You've bought yourself a domain name, you've bought yourself mywebsite.com, and you've then got to move all of the media from your computer onto the web space. And you do that using FTP, File Transfer Protocol, because you couldn't use email, because email's from send information from one user to another. You're actually moving a lot of data, and this is where FTP is really handy. So it's the protocol set of rules that's been created to transfer files across a network. Often involves using a username and password, and you've literally got, I could try drawing this. Everyone loves my diagrams. So if you imagine the web page, there's your screen you're looking at, and you've got, I could use this arrow here, and your screen is split in two, and on this, that was really not very clever. There's my screen. Let's try this again. Oh, okay, this time I'm going to focus and not do the same thing again. There's my screen. There's my arrow. and it's split in two, my screen. That's not quite two because I'm not very good at art, as you know. On this side are my files, and on this side over here are my server's files. That's my web space. So you simply, on this side here, you put all of the files you want to send, and then you click send, and it sends it all across to here. It was just an excuse to use my my arrows, which I think are pretty cool. Humza, how are you, dear man? Good to see you. Welcome to the show, Humza. Things are pretty good, I've got to say. Things are pretty good. Yeah, FTP, so that's that one. Here's my beautiful diagram that I spent ages making, and I've written important again. It's called File Transfer Protocol, and it's about transferring files between any two nodes. That word nodes, I should draw an important arrow to. That's a triangle. That's not a triangle, it's a rectangle. Let's do an arrow. Can I do an arrow? Come on, arrow. There it is. Nodes, that one there. A node could be any device on a network. So it could be a router, a computer, it could be a mobile phone, it could be whatever you need it to be, all right? So that's what a node is. And they use that phrase sometimes in the exam, so don't forget. Mohammed, dear man, how are you? I missed you. I was wondering where you were. I hadn't taken it personally. I hope you all survived today without me. I had to go and do a very boring meeting. Yes. So, POP and IMAP and SMTP. These three are to do with email. One for sending, two for receiving. And of the two for receiving, one's older and does less, and one is newer and does a bit more. Right? That's the sort of overview here. 25, good numbers. Okay, so we've got Post Office Protocol first of all. That is this one here. And Post Office Protocol is a set of rules or protocols written for receiving emails. So we talked about a server earlier, didn't we? A server is usually a powerful computer. It's got attached storage, and when you open an email, you're actually downloading the email from a web server. So your client, so I use Outlook for emails. Your email client, Outlook, you're then dragging down the emails from the web server. So these are the rules for how that happens. So the emails are downloaded from the web server to the client server. And if you remember all this talk about clients and peers, and that's the difference. The client is you, the client server, and the emails are removed from the server. So that's the key thing with this type of protocol, is that with the Post Office Protocol, the emails are actually removed from the server altogether. Okay, and then you've got IMAP, this one here, where same thing. It's the protocol that's used for drawing the emails down from the email server, except the emails remain on the server, which means that you can sync your emails across devices. So can you remember how if you were looking at emails on one device and then opened your email client on a second device, the emails you'd open would show as being red or greyed out? That is, yeah, top of the table. Let's just see how that lasts. So that's the difference, is that it allows syncing. I'll go into a bit more detail, but the IMAP is the newer protocol and the one that generally we use these days. POP's quite old and not really used. And SMTP, that's the protocol used for sending. So two for receiving, and the two for receiving are these two guys here, and the one for sending is that one there. And you need to express in the exam the difference between Post Office, the POP, and the IMAP. Okay, so that is your job there. Right, what have I got left here? I've got this one. Come back. Yeah, we go. All right, come on. No, back one. Get back there. Okay, POP. Again, I'll ping you this PDF so you've got all the details, but what it's called, what it's used for, and the difference between IMAP and POP, that's your takeaway from here. Where are we? 54. What's that? Nearly half an hour. Okay. We are most of the way there, by the way. I just got layers to do, and then we're sorted. So what I've got important there, that's the stuff that you need to make sure you can you can repeat in the exam. And they're likely to ask you, what does it do? What's its purpose? You see down here, I've pinched this from the specification. Need to know its purpose and its key features. In other words, what's it for and how does it work? What's it about? Okay? So that is the... Okay, a very good question, Jelly. What's a mail server? Right. It's a mail server is it's a computer which has got storage, like hard drives attached, and it's a place where your emails, when they're sent to you, are stored. So if you imagine that someone sends you an email, it doesn't go directly to your phone, it goes to your email server first, and then the email server sends it to your phone. Now, you discover fairly quickly that if you turn on, you know, in your mail settings, you can set your email to be constantly searching for emails, but it really drains your battery really quickly. So generally what I do is when I want to use my email, I then open my email client, open up Outlook on my phone, and whether it's web or whether it's an app, it makes no difference. And I then sort of click on my mailbox, and it then contacts my email server, and it says, are there any new emails? And it has a look and goes yes, and then it just downloads them for me. So the mail server is the server that holds your emails and where you send your emails to, and then it forwards them for you. So that's what email is. Jelly, does that make sense? Do we have them on our phones? Okay, we don't have. We only. The phone that you have is only used for drawing it from the server. The server is accessed via the cloud. So in other words, you access this computer and this storage, your email server, using your phone and using the internet, but you don't actually have the server on your phone. The server is a big, powerful computer doing that. Does that make sense? That's a really good question. Because it's kind of. Yeah, it is quite complicated, but you've got a company like Hotmail or Outlook or Yahoo Mail doing that heavy lifting for you. So all you've got to do is send your email from your phone to the mail server, and it forwards it for you. And then all you've got to do when you want to see your email is to open up a connection with the mail server and then drag your emails from the mail server to your phone. Does that make sense? That's kind of how it works. Who else have we got here? We've got Laura here, we've got Colden, we've got Mohammed here. Sir, call me Nike and call Holmes and McDonald's. I don't want to get involved in any abuse between you two. Hi, Awana, nice to see you. Yeah, hi, Pablo. I saw Pablo. How are you doing? Good to see you. Good. I'm glad you get it. I hope all my waffling kind of got it there. That's how it works, okay? That is, and I do think, though, what a nice dog. I think it always really helps, just rather than teaching the facts. It's kind of, if you understand what the thing is doing, why it's there, the story of it, it makes a whole lot more sense. We've got loads of you here. This is excellent. I'm not sure Pablo's a nice dog. I like dogs. Dogs are nice. We've got Pop. So this is Post Office Protocol, and the important bit is it provides a mechanism for retrieving emails from a remote server. So Jelly, going back to what you asked me, this is what it does. These protocols are the rules for how you get your email from the server to your phone, or from your phone to the server if you're using a phone, okay? And the important thing is that with POP, once you download your emails from the server, they're no longer on the server, they're deleted. So that's rubbish if you want to download it on your phone and then you want to go and sit on your laptop and then look at your emails, because it won't be there. So that's why everyone uses IMAP now. And you can do things like flag messages, you can sync messages, you can do all that sort of stuff, okay? And it also supports multiple mailboxes. So that's the advantages and disadvantages bit, which is so important. Okay, this is now the last bit. We're on to layers. So big deep breath, because I'd be very interested to see that. If this is true, Pablo, you have to let me know. This is a trick I didn't know you had. The TCP IP 4-layer model. Right. So look, this is an abstraction of how protocols actually work. So, you know, we talked about these protocols. We talked about POP, we talked about IMAP, we talked about HTTP. Each of these protocols sits on something called a layer. And these are 4 layers here. We've got the application layer, the transport layer, the internet layer, and the network interface layer. And those are the only 4 that you need to concern yourself with. Now, it's useful for you to know that they do have jobs. The application layer is to allow access to network resources. That's the one the human will get involved with, like applications like a browser, applications like a web client. Then you've got transport, and that's about message delivery. And then you've got the internet layer, and that's about packets. And then you've got the network interface, which is for transmission between 2 devices. So they each do subtly different jobs, and they each become more abstract as they go from the top to the bottom. So this top bit here, at the start of the arrow, that's more what humans do. And at the bottom, that's more to do with data being moved around, the more abstract stuff that you don't see, okay? So that is a bit of a help with how that works. Here's what you need. Layers. It's a division of network functionality. That sounds like a really horribly complicated phrase, but what it means is that each layer does a different thing. Okay, each layer is responsible for doing something different. And the purpose of layers is that it divides the very complex notion of programming and moving data into separate functional components. And they're organized hierarchically from top to bottom in layers. And crucially, each layer only communicates with the layer either directly above or below it. Okay, so those are the key takeaways from layers. They love to ask you, so by the way, if they do ask you, let's just go back one step. If they do ask you what a layer is, if you learn any 2 of these, this is a good one and this is a good one, okay? Those 2 will probably get you the marks that you need to ever talk about layers, all right? Then, what are the benefits? So now you can explain what a layer is. It's about network functionality, all right? What's the benefit of organising things in layers? Rather, because the alternative is you write one big set of rules that covers everything, that covers email, that covers the World Wide Web, that covers TCP/IP. You just write one big set of rules. The advantage of doing it in layers is that a layer can be removed or changed without impacting the other layers. Hello Ziggy, how are you? Good to see you. So that's the advantage, right? Each layer is self-contained, so it can be programmed individually. So different companies can change different bits about different layers, and it's not going to impact everything else. Different layers usually work with different hardware. So one will work with the router, one will work with the switch, okay? One will work with different protocols. That's how this thing is set up. And this makes individual protocols easier and simpler to manage. And it means that developers, so companies, can focus on one part of the network at a time, rather than changing one thing and then having to rewrite the entire protocol. So it makes the protocol smaller, more manageable, and it makes the whole thing work much better. This word appears in every single mark scheme, interoperability. Let me get rid of that so you can see it. This one here, interoperability. The idea that this means that companies can work together, companies can share informations more effectively, okay? So that's that word, interoperability, working between different companies and vendors and manufacturers. That's a really important reason for a big benefit of layers. All right. These are the different, I'll just ping you this, I'm not going to run through this, there's way too much in there, but that is a bit of further information for you on layers and what happens in each layer. So this first layer, and by the way, you don't need to know this, but so the bottom layer, the network access link layer, do you remember I said they work with different devices and therefore different protocols? Yes, this is a very pressing question. I'm beginning to wonder. I think it should be strictly controlled. So this one, the network access, and link layer works with, oh my word, I wasn't going to do that. It works with, come here. It works with cables, repeaters, hubs and switches. So therefore they can write software and sets of rules to deal with that, okay? Let's have a look at the next one, which is the next one up, which is the internet layer. And this is the one that deals with IP addressing and routing. And this deals with IP addresses and it deals with packets, okay? Then we've got the next layer, which is the transport layer. And this one is to do with TCP down here. And it's about communicating between hosts. So, and you don't need to know this, but I think it's quite interesting because I am quite sad. Internet layer. Okay, and we've got the fourth layer, which is the application layer, which uses these protocols here, FTP, HTTP, and so on. All right. So as long as you've got this idea, you can describe what a layer is, what the benefits of layers are, and you've got this notion that these protocols that you're learning, they sit on different layers. Okay, and it promotes interoperability. That is all that you really need to worry about there. Okay, I think we are done. Let's jump into quiz time because I think that is the logical thing to do. Okay, fingers on buzzers, please. What does HTTPS, we've had 27 in today, what does HTTPS stand for? Oh, look at Krish, he's like a man possessed. He says B. Any more answers on that? We've got Ziggy, we've got Jelly who said B. We've got sound effects keep getting better here. I sadly wrote that myself, which is really tragic. We've got Laura with B. We've got Oana with B. We've got Ziggy with B. We've got you guys are absolutely there. Okay, so that is completely outstanding. What more can you ask for? Right, what about this one? Which two of these protocols deals with email? So I want two answers here. No pressure at all. Humza says A. I'm looking for two though. Ziggy says A. You're hedging your bets here. Krish says D and C. Jelly says A and D. Ziggy says D. Oana says A and D. What do we think?
I got a bad feeling about this.
Extra bonus marks if you know which film that is from. Rukshan said A and D. So there's a lot of A and D-ing going here. Should we see if the A and D gang are spot on? The A and D gang are correct. Well done. That is outstanding. So what about this? No, it wasn't Top Gun. It wasn't Top Gun. You can have it one more time.
I got a bad feeling about this.
Okay, so what about this? What is a protocol? Nice, easy first mark when you're doing this in the exam. What is a protocol? What do we think? Well, we've got quick marks here. We've got Mohammed who's come back with a random answer. We've got Rukshan who says A. We've got Krish who says A. A set of rules for how something behaves. Pablo's gone for A. Jelly's gone for A. Oana has gone for A. Let's see how we are doing with this. It is, and if I could just press the right button, it is A. That is outstanding. How do I get rid of my scary organ? Yeah, that was quite annoying. All right. What about this one? Let's try this one. What does FTP stand for? I'm only doing this one to annoy you. Ah, Mohammed, you are outstanding. It was Star Wars. That is a very accurate answer. So hang on, we've got Jelly who says C. File transfer protocol. We've got Ziggy who says C. We've got you. Did you say it first, Laura? I take it all back. Did Laura say it first? I shall look back at my comments. You did say Star Wars. You were the star, right? You get the applause. Forget that, Mohammed. I didn't realise. I take it all back. Didn't make you wrong, though, Mohammed. We've got my star students. We've got Humza with F. Thanks, Humza, for coming. We've got Pablo. We've got Oana. We've got... Oh, did you say that was... Oh, God, I'm... Look. Goof. But... What is Hannah's... Yeah, by the way, you were right, by the way, is the answer. Laura, you were right. You're the real star of the show. Laura and Jelly. There we go. File transfer protocol. That's what it was, okay? What about this one? How much of your time have I wasted? What time is it? 1910. Okay, we've got a few more of these. Transmission control protocol splits data into... what? It's getting personal. Dom, you're so quick. Dom just gets in with packets straight away. Is she right? She is right. And so was Pablo. So was Jelly. So was Krish. So was Iwana. So was Rukshan. So was Humza with a spectacular spelling. And Rukshan and Laura. Okay, outstanding. Let's push on. Come on. Oh, this is so annoying. It does this each time. Here we go. Which layer of the TCP/IP model splits data into packets and reassembles them at destination? I don't think you know this. There's my challenge.
Quite an experience to live in fear, isn't it?
Okay, I very much doubt you know which film this one's from. Bit before your time, this film. One of my favourite films, actually. Any idea? Oh, and there's the quiz question, by the way. Laura has said B. Oh, let's jump forward. Laura said B. Dom said B. Jelly said A. Humza says network, which is B. Rukshan says B. Rukshan says network, which is B. You guys are Bing it. Okay, shall we see if you've got a B in your bonnet? So I did there. It was D. You're all just you're all miserable people. What about this one then? What about this one here? In the layer model, if one layer is improved, what happens to the other layer? Oh, let's have a look. I got saved now. I think that Laura said C, Krish said C, Rukshan said C. I've got a dog desperately trying to break in. Who does break in? She's unbelievable. She has to come in. I've got a Rukshan with a C. I've got a Pablo with a C. Okay. Let's see how you're doing. The answer is It is C. That was outstanding. Okay. All right, guess the question. Oh, don't spoil you with a random range of questions. Guess the question. So this is the answer. I should probably explain the question. This is the answer. I took this from a mark scheme. This was the answer in the mark scheme from a GCSE mark scheme not that long ago. What do you think the question was? Wise words from Ziggy. What do we think the answer is? Okay, so yeah, that is pretty good, Oana. That is pretty good. What are layers? Yeah, what is a layer? Oh, you guys are good. Should we have a look and see? The question was, with regards to network protocols, define what's meant by a layer. So that's what they were asking for. But any of those sort of the list of 4 things I gave you would work really well, okay? But they said, let's go back one step. The answer that they had was a division of network functionality, which is a... no, I know, Dom is on fire. She's so quick. I think she's got a very fast internet feed. That's my theory. She maybe is using a fast medium. What could the fastest wired medium be, I wonder? We covered that last time. I wonder what could it be? Revision ideas. I think we're done. Okay. Ideas for what you can do. So, create a table for the protocols. So learning those protocols, get those inside your head. It's nice the fact you can get this done, 4 months ahead of time and put that away. You might want to use some mnemonics to learn it. You know my stupid diagrams with the TP and the TP with the S and M on the front of it, and then you've got the bowl of peas. If that works for you, use it, okay? And storing those in a room, doing a mind palace with those, it might take you 5 minutes to do it, but it could be useful, and you've just got it stashed away there. And then all you've got to do is figure out what these things do, okay? So create some tables, learn some basic information about each layer, what they do, explain what the benefits of layers are. Do some skills around the hex, binary and denary and those binary shifts. The maths involved in that is really easy, but make sure that you're happy, because with all of the binary and hex stuff, once you've drawn the table, do you remember that table you've got to do? 1, 2, 4, 8, 16, 32, that table going from right to left. Once you've drawn that, it's easy. But go back and remind yourself. Don't make it in 4 months' time you're doing it for the first time, because that'll be a nightmare. Memory registers, looks like you know them, guys, which is great. And I put there, spend a few minutes learning Python. I recommend going and looking at these past paper questions on coding, and we'll carry on this term doing one of those at the start of each lesson so you get a better idea. And use that retrospective revision planner that is sitting in Satchel 1 somewhere that I sent you to tick off the stuff you've done. And then you'll find that you've actually got quite a lot of this syllabus already ragged. 1916, 46 minutes exactly. How wonderful. Guys, it's been an absolute pleasure. We've had a lot of people in today, so that's really good. Thank you ever so much for coming, and I will see you all tomorrow. Have a lovely evening. Bye-bye, bye-bye.